Hello and welcome to our third session in this junior programmer series. And in our previous session, we had positioned the vehicle at the start of the road with an obstacle right in its path. Well, this is not a parking simulator. Actually, what we are building is a driving simulator. So, in this session, we are going to give that vehicle a little fuel, and so that by the end of this lesson, the vehicle will drive down the road, crashing through the obstacle in its way. In Unity, all of the game objects in your scene are made up of components. It's these components that determine how your game object will look and behave in the scene. So if you want a game object to behave differently, you just need to change its component. So let's take our vehicle for example. Right now, it doesn't have any component. It just sits there doing nothing. It doesn't even obey the law of gravity. If you raise it up in the air, it would just float like a vehicle-shaped cloud. But if you add a particular component called Rigidbody that tells it to obey the gravity, it will fall. What we need though is a custom component that will make this vehicle drive down the road. So we are going to create this custom component by programming it from scratch in a new C# script. After we write the code that will move a game object forward, we will apply the script component to our vehicle and our vehicle will move forward. As you will quickly find out, programming is very powerful. Just a single line of code will make the vehicle fly down the road. So to make it all that happen, let us enter into the world of Unity. In the previous session, we imported all the assets and we got this course library, and in scenes we had this drive simulator scene. We also added a vehicle and an obstacle. Now in this session, we are going to make this vehicle move using code. We have to now first create a script component. For that, I will come into the project window. I will come into the asset. I will right click, and first I am going to create a new folder, and I am going to call this folder as scripts. When you are working in Unity, always organize all your content in correct folders. Say for example, you have course library, and if you open it, all the obstacles prefabs are placed inside obstacle, all the sky objects are placed inside sky, all vehicles are placed inside vehicles. And similarly now, I will close course library, and all the scripts that we are going to use in this project will be placed in the scripts folder. Let us create our first script. I will right click, come into create, and you have the option here MonoBehaviour script. Click on this. You have to immediately rename it correctly. For example, now I am going to rename it as player. Remember, P is capital, controller, and press enter. When you are writing multiple words, we cannot use space in script names. So we use a technique called as CamelCase. CamelCasing means the first letter of every word will be capital, like P and C are capital. This is just a convention used by developers so that they can clearly understand the words better. Once I select this player controller in the inspector, you can see the preview of your code. See, as soon as you create the script, in public class, you will have a name and it will be also called as player controller. This name and the name of your script should be the same. Sometimes what happens is, say I will come into the script, I will come to create, and I create a MonoBehaviour script. I am going to call this something like obstacle, and you can now see as soon as a script is created, it will compile. This obstacle, right now the name is same. However, after some time, if I just right click on this script, if I rename this as player, you are going to get an error. This is because the name of the script is player, but the name of the class is still obstacle. Always, when you change the name of your script, you should also change the name of the class in the script. Keep this in mind. Now I will select this player script. This is not required. I will right click and I am going to delete this. And in confirmation, click delete. I want this player controller script to be attached to my vehicle. I can attach a script to any object in three different ways. The first way is I'm just going to select it and drag it onto this vehicle. If you come into the inspector, you have first the transform component, and then you have the mesh filter, you have mesh renderer, mesh collider, and you have the newly added script component PlayerController. So right now I will go to edit and undo this, and the second way of adding is I can select vehicle or any component here, and I can drag this script directly from here into the inspector window. So now you can see the PlayerController script is added. And now if you want to remove any component or any script, I can click on the three dots on the right hand side and choose remove component. Now the third way of adding this script is, if vehicle is selected, you have one add component here. Click on this, and I am going to now search for this PlayerController. So when I create a script, it will be available in the component, and now I can select it and add it. Now it is time to edit this script. To edit this script, we are going to make use of a software called as IDE, Integrated Development Environment. Now Unity comes with Microsoft Visual Studio, but for our application, we are using a different IDE, Visual Studio Code, again from Microsoft. If I come into edit and if I come into preferences, in this preferences setting, on the left hand side, you have one option here, external tools, and in external tool you have external script editor, and this has been set to Visual Studio Code already, because in our installation video we have already installed Visual Studio Code. Or if you have any other IDE, you can browse to that folder and you can use that IDE. So right now I have set it to Visual Studio Code. I will close the preferences window. If I select this PlayerController script and if I just double click it, this is going to now launch Visual Studio Code, and you will get a display here. Do you trust the author? Click on yes, I trust the author, and you can now see this PlayerController.cs file is open here. When I am using this, there are some errors appearing here. This is because when I have installed Visual Studio Code to work with Unity, I have come into the extensions and I have installed some extensions. I had installed debugger for Unity, but for the latest version this is not going to work, so I am going to uninstall it. So I have to use the Unity extension. So I will come into Unity extension, and this is already installed. So now I am going to now click on restart extension, and I have already removed this debugger for Unity. I can come here, select this, and have removed it. Come here and type Unity, select this Unity from Microsoft Studio, and you can install it. And also I have to install another component here, which is C# component. So you can see that the C# development kit by Microsoft, I have to install it. I have already installed it, and C# also is installed. You have some errors here because I have not installed the latest version of .NET SDK. So I will close this external C#, and you are seeing the error. I am now going to come into my browser and I am going to search for .NET SDK. And the very first link here, you can see here .NETMicrosoft.com. If I click on this, this is going to take me to the Microsoft site, and you have .NET 10 SDK into 64 version. So I am going to click on this and I am going to now download it. Click on the arrow here, choose download unverified file, and once it is downloaded, I click on the folder here, and selecting this, I will just double click and I am going to click on the install button. It is asking me to close some applications. Click on OK, close Visual Studio Code. The installation is going on. Once the installation is complete, I will click on the close button here. I will come back to Unity, and again I will double click on PlayerController so that Visual Studio Code now launches, and right now I doesn't have any errors. I can type this code even in a text document. press Ctrl A to select, right click and I am going to copy it. I am going to come into the Explorer, right click and I am going to create any text document, and this text document I can give the extension as .cs, and in this I can type the code. When I am typing the code in text document, if I do some spelling mistakes, I will not be able to identify which is the class name, which is the module name, which is the method name. Whereas in an IDE, all this will be color coded. See, UnityEngine is green, PlayerController is the name of the class, it is green. See, start is yellow because this is a method, and this line is dark green because this is a comment. We get visual cue, and also it will help me with code snippets. So this is the reason why we make use of this IDEs. In Visual Studio Code, on the left hand side, you have the Explorer. This Explorer is similar to the project panel in your Unity. So if you come into Unity, you can see the project panel, and just like you have asset, folders, all the structure, similarly in Visual Studio Code, I have the structure here, and you can see inside the script folder, I have this PlayerController.cs. You also see the course library here. In this PlayerController.cs, in this C# script, the first line we are calling is using UnityEngine. This UnityEngine is a library of codes or methods which you can import into this C# script. You are going to start your entire code with a class name, and this class name will be equal to the name of your file, and this class is derived from a built-in class in Unity which is called as MonoBehaviour. So MonoBehaviour is already a set of class. Predefined classes, methods are present inside this MonoBehaviour class, and we are going to assess all these classes in this PlayerController class. And in MonoBehaviour, one of the most popular method that we use is the start method and the update method. And another thing you have to know here is, when I start the PlayerController, after I declare the name, I put the colon and I will type MonoBehaviour, and then this entire class starts with a open flower bracket and ends with a closed flower bracket. And whatever is present between this open and closed flower bracket is the code that will be executed by this class PlayerController, and we call this as code blocks. And inside PlayerController, I have two methods. One is the start method, and in the top comment it is mentioned whatever I type inside this start method, this will be executed as soon as the game starts. Similarly, when the game is running, you have another method called as update, and whatever code I enter inside this update method, this will be called for every frame. That is, every frame when the game is loaded, this script will be executed. If we want to move our vehicle forward, then I have to add the corresponding code in this update code block. And inside this open and flower bracket, first I am going to just declare what I really want to do. I want to move the vehicle forward. This move the vehicle forward is an English language sentence which is for coders and programmers to understand. C# or UnityEngine is not going to understand this. I am going to convert this line into comment. If I add 2 forward slashes at the beginning of the line like this, and if I press space, you can see this turn dark gray, and this is a line which is for our reference, and UnityEngine or C# is not going to execute it. This we call in programming language as comment. Normally, in our English sentences, we complete a sentence and we end it with a period or full stop. Similarly, here I will delete it. In case of C# or Unity, for C# or Unity to understand that this is the end of a particular line or command, we use semicolon. After using UnityEngine, you have semicolon. Let us come to update and let us add our actual code. I have to first understand what I want my program to do. So if I come into Unity, if I select my vehicle, I want this vehicle to move forward. To move forward, what is the component we are going to use? If I select the car and if I come into the inspector, all this movement is in the component transform. And in transform, you have position, rotation and scale. And in position, I want this to move forward means I have to hold this blue Z axis and move it. As I move, you can see the Z value is changing. That is, I have to move this along the Z axis in positive direction. I will leave it here, go to edit, undo and set it back to 0, 0, 0. We are going to do the same thing using code. So coming back to Unity, after this move the vehicle forward line, we are going to tell Unity to call the component transform. See, you can see automatically the code is giving you a hint. Inside transform, I can do scale, rotation, position. There are so many features. I will add a period and I am going to call translate. See, as I type, you have translate. And remember, in this translate, T is capital. For this translate, I have to give a parameter. I have to tell Unity in which direction I want this to translate or move. In open close brackets, I will end it with semicolon, and inside this open close bracket, vector 3 means I have to give 3 axis values. The first axis value is x. Along x I doesn't want to move it, so I will type 0 and then I will press comma, then I will press space. Along y I does not want it to move it, so I will press 0, comma, I will press space and then press 1. I am going to close this code and I have ended it with semicolon. Now I will go to file and save it. Don't forget to save it. If you doesn't save, the code is not going to work. Now this code is in our English language. This has to be converted into a machine language. To convert our English language code into machine language, we use a process called as compiling. Now if I come back to Unity, then immediately you can see now compiling scripts. The script is getting compiled, and once the script is compiled, I have to come into Window, General and open this console window. There should not be any error in the console window. For current purpose, I will drag this console window and put it next to the game view. In console window, I doesn't have any error. If I come here and save this and if I execute the game, you can now see that the car ran away like a rocket. So I will stop the playback. We are able to move our car in the forward direction using just one line of code. Now coming back to Visual Studio Code, see this Transform.Translate 001. This type of code was used in Unity about 6 to 7 years back. And as newer version of Unity is released, these codes are actually modified and made more user friendly. So instead of typing 001, I will leave this code as it is. I will press enter and again I will call transform. And whenever I am typing, because I have installed Unity extension in Visual Studio Code, I am able to see all the Unity C# commands here. This is like a dictionary. Just like in English when you are typing, it shows you the correct spelling. Here it shows the correct syntax, and here for transform T should be small. So I can select this transform, then automatically it is showing me rotate 010. I will press period, and if I just type TRA, I get translate. In open close bracket, I will end it with semicolon, and inside this translate, instead of typing the number now, this 001 number we call it as vector 3. Vector 3 means values in 3 directions. I am now going to type vector 3, say I get it, and automatically it shows me the code hint. If I press tab, I can fill it up. So right now I will press period and I just type forward, leave it. Instead of typing 001, I can just type vector 3 period forward, and it is going to move in forward direction. Similarly, vector 3 backward means it goes back, vector 3 left means it will go to left, right means it will go to right, up means it will fly. So now I will select the first line here and I am going to delete it. I will again press delete and move this and align it correct. I will go to file and I am going to save this. I will come back to Unity and again the script is getting compiled, and once it is compiled, see that in console you doesn't have any error. Now if I execute the game again, you can now see you have the same effect. I will stop the playback and in the top view, I will right click and turn around in another direction like this, press S and I will move back. See, I will keep this direction. If I play now and show it to you, see the car is flying away. So I will stop the playback. Now if we want to understand the logic behind this code, if I come back to Visual Studio Code, we have this vector 3 forward. And what does this vector 3 forward represent? It is moving vehicle along the z-axis by 1 meter for every frame. So every frame this vehicle is moving by 1 unit along the z-axis. So now if I come back to Unity, when I come into the game view, you have one stats button, and if I click on the stats button and if I now execute the game, you can now see it is showing FPS, and currently on my machine it is showing around 300 frames per second, and this FPS depends on the machine's graphic card. If you doesn't have a good graphic card, it might be showing 30 frames per second, and in my case it is showing 300 frames per second. In my machine, it is going to move 300 units per second, but in an ordinary computer, it will be moving only 30 units per second. However, in my game, I want this car to move at the same speed irrespective of the machine graphic card. I will come and stop the playback. I want this to move just like other vehicles where the speed is calculated with time. In Unity and in most of the game engine, we use a value which is called as Time.deltaTime. Now in this Time.deltaTime, see carefully, the first T is capital, D is small and T is again capital. And what does Time.deltaTime represent? In Unity or any game engine, Time.deltaTime is equal to the time taken by your machine to render one frame of the game. So it is going to calculate how much time your machine is taking to render one frame. In case of a high-end 1000 frames per second machine, Time.deltaTime will be equal to 1 divided by 1000, which is equal to 0.001. Whereas in case of a 100 frames per second machine, Time.deltaTime will be equal to 1 divided by 100, which is equal to 0.01. Coming back to the scenario where we had added vector 3 forward to our car and our car was moving at a speed of 1 unit per frame. If you are running this game on a high-end 1000 frames per second machine, then for every second the car is going to travel 1 into 1000. That is 1000 meters in 1 second. So it will be covering 1 kilometer in 1 second in case of a high-end fast machine. However, if I now take this vector 3 dot forward and multiply it by Time.deltaTime, then this 1 into 1000, in this case Time.deltaTime value is 0.001. So finally, the speed of the car will be 1 meter per second. So instead of traveling at 1 meter per frame, when you multiply it by Time.deltaTime, it is moving at 1 meter per second. If you come to a slow end machine, again here we have set the speed to 1 unit, and here the frames per second is just 100 frames per second. Then it is going to travel 1 into 100 meters per second. In a high end machine, it will be moving at 1000 meters per second, and in the low end machine it will be running at 100 meters per second. And now in this case, if I multiply this value by Time.deltaTime, then you can see now 1 into 100, and in this case Time.deltaTime is equal to 0.01, and again speed of my car will be 1 meter per second. Now in our game, coming back into this player control script, coming into this 16th line, Transform.Translate vector 3 forward, I am just going to now multiply this value. Automatically it will show me the tip. I am going to multiply it by time. See, you have the hint showing time. I am going to press period and you have delta time here. If I come to file and if I save this file, I will come back into Unity and allow the script to get compiled. I will close this statistics. Then I am going to play the game and you can now see my car is moving at 1 meter per second. 1 meter per second means if you calculate it, the car is approximately moving at 3.6 kilometers per hour. I want this car to move at a faster speed. I want to move my car at 40 kilometers per hour. I am going to come into Google and type meter per second, kilometer per hour. You get a converter here, and if I want it to run at 40 kilometers per hour, then I have to move it at a speed of around 11. Then I have to come back into the script, and this time.deltaTime value I am going to multiply this by the number 11. Now I am going to come to file and save this. Now coming back to Unity, allow the script to get compiled, and then if I play the game, you can now see my car is moving at 40 kilometers per hour. So now I am going to stop the playback. If you observe the game, the car is going and traveling through my obstacle, which is not natural. Now I will stop the playback. I select this car here and I am going to move it along the y-axis by around 3 units. I will now go to file, and if I save it and if I execute the file, you can now see that the car is flying, which is unnatural. A car cannot fly like this. I will stop the playback. Now I want this car to follow the rules of physics. You know Newton's laws of motion, and none of this law is applied to this car. Now the beauty of Unity is the Unity has adapted all Newton's laws of motion and all physical laws into one single component, and this component we call it as rigid body. So now with the vehicle selected, if I come into the inspector, right now I will close all the components here, 2, 3, 4, 5 components here and a material. I am now going to add a new component. I will just type rigid, and you have rigid body. Now once I add the rigid body, you have some parameters here: mass, linear damping, angular damping, automatic center of mass, automatic tensor, and most important thing is use gravity. If I enable this, and now if I save my file and if I now execute it, you can now see the car drops down and it hits the obstacle and it gets accident and falls down. See, I will stop the playback. All the physics rules are applied to my car. I will come back now here into the transform and I will set its y value back to 0. So right now the weight of my car is set to 1 kilogram. And if I play the game, now what happens is it is going to go and hit and the car is going to get crashed. So I will stop the playback. Actually in reality, the weight of my car is not 1 kilogram. It will be a minimum of 1 ton. So I will change this mass to 1000. And then now if I play the game, you can now see that since the car weight is more, it stops and you can see now it rolled out. You can see how the physics behavior is changing. Now I will stop the playback. Now for this rigid body to work, one more component to be added to the game object. And this component we call it as mesh collider. This mesh collider is already added to my car. Why is this getting blocked here? Because if I select my obstacle also, this has mesh collider already applied. So if I now switch it off now, and now if I play the game, you can now see the car goes and moves inside it. It has no effect at all because I have not enabled collider. So if I enable collider, what is this collider? It is an mesh that is drawn all around your object. So if I press F and zoom in here, see if I switch off mesh renderer, you are seeing this light green lines. This is what we call as the mesh collider. So I will enable mesh renderer, and even for this collider, you doesn't have rigid body. So I will come into add component now, and I am going to add rigid body to it, and its weight is set to 1 kg now. So now if I save this and if I play the game, you can now see when it comes and hits this, see this is rolling out and falling out like this because this has just 1 kg mass. If I stop it, normally this kind of crate will not be 1 kg, it will be a minimum weight of 100 kgs. Now if I save this and if I execute the game, you can now see when it comes and hits how the behavior of my crate is going to change. I am going to stop the playback. Using this rigid body and playing with mass and gravity value and all these things, you can simulate in real world how actually objects of different masses behave. Now let us add some more obstacles on the road. The very first obstacle is placed at a distance of 25 from the z-axis, and I want to place it almost equidistant at the same 25 unit all through the road. So for that I will select the obstacle here and press Ctrl+D. This is going to duplicate the obstacle, but the duplicated obstacle is at the same position as the original one. Now I will come to the position, and for this 25 I will add plus 25 and press enter. See, automatically it moved. I will select obstacle with Ctrl plus obstacle 1, press Ctrl+D. Now I have another 2, and I am now going to move it by next another 25 units. What I can do is, you have one option here called as snapping. I will come into snapping, and with this constraint proportion on, I will set a distance of 25 and I will enable snapping. And with this obstacle 2 and 3 selected, I will now move it along the z-axis, and you can now see it snapped by 25. I will again move it again to snap it by another 25. I will middle mouse click pan and come forward here. So I will press Ctrl+D to duplicate these two. Then along the z-axis, I will again drag 1, 2, and then I select the last one here, and if required I will right click and come into the top view. I will just zoom out to see the entire area. With right mouse I will just turn around to see it from a different angle. I will select only the last one here, going to press Ctrl+D, and I am going to move it by next snap, which is by 25 units. I have total of 7 obstacles here. Now I will switch off this snapping. I will select the first obstacle. With shift pressed, I select the obstacle 6. All the 7 are now selected. I will right click and choose create empty parent, and I am now going to call this as obstacles. So I have organized all these obstacles inside an empty game object called obstacles. Now I will go to file and save it. Right mouse click, tilt up, press Q to move down so that I can have a view like this. And then now I will go to file and save it. I will deselect everything. I will click the play button, and now you can see the car hits the first obstacle, the second, the third, and then the fourth, then fifth. I will right mouse click and turn, sixth, and then the seventh, and then you can see the car just falls down to the ground because gravity is applied. I will stop the playback. We are going to conclude our session, and we have now learnt about rigid body, colliders, and we have also written our first one line of code to move our car. So let us meet in our next session.